Alrighty, so the theorem of Pythagoras. What is the theorem of Pythagoras? So essentially, this mathematician, Pythagoras, many years ago, came up with a way or a theorem that allows us to find the length of any side in a right angle triangle. So I just want to draw this in a bit better here because I didn't. We can see that we've got triangle ABC in this diagram here, and we can see that it's a right angle triangle because of that little square in the corner. That square is telling me that it's a 90-degree angle. And so the theorem of Pythagoras works only in right angle triangles. And what it allows me to do is it allows me to find the length of any side in my triangle. Now, Pythagoras' theorem states that we would take the hypotenuse squared. Now, we need to know, obviously, what the hypotenuse is. The hypotenuse is always the side opposite the right angle, and it is the longest side. So in this case, AC is my hypotenuse. Yeah, that looks fine. And so if we want to now work out its length, we would take the hypotenuse, which is AC squared, and then essentially equate that or make it equal to the sum of the square of the two other sides. So the other two sides are AB, and we would square it, plus the third side, BC, and we would square it. And this is the theorem of Pythagoras. If we take the square of the side or the square of the length of the hypotenuse, we essentially get the sum of the square of the two other sides. And this is the theorem we need to be able to apply to finding lengths in right-angled triangles. Okay, so there's a little video that I want us to watch to hopefully try and explain this. You don't have to stress too much about it. It just sort of explains how this works in terms of Pythagoras' theorem. So let's hope it works. It did in the last one, but we'll see now. Okay. Give it a sec. All right. Can we all see the video? I don't know why it's so small all of a sudden. It's fighting with me.
Now we can see it.
Okay, so fun little thing to basically show you how Pythagoras' theorem works. It is taking essentially the square. I don't know what's happening with my screen. We're just going to give it a second to write itself. It's essentially saying that we take the two sides that are not the hypotenuse, and if we square them, we get the square of the hypotenuse. Now, if we go back to this diagram here, this actually shows us that. Okay, right, we got there in the end. If I look at the length of, well, it really doesn't matter which side we work with. If we look at the length of, say, for example, side AB, this side is 3 blocks long. And so if we square 3, we get 9. And that's why I've drawn 9 blocks here. That is the one side AB squared. If I look at my second side, which is BC, I have got 4 units here. Now, if I square 4, I have 16. So 4 squared is 16. And so we can see that I have got 16 blocks here. So that is my side BC squared. Now, if we think about what is the sum of those two things. So what is 9 plus 16? So the 9 blocks plus the 16 blocks, we know we get 25. And according to Pythagoras, that is saying that I should have 25 blocks for my hypotenuse squared. So let's go and have a look if that is indeed the case. Let's just get a proper highlighter going on here. So I can see that my length AC is 5 blocks long. And if I square 5, I get 25 blocks. And so it is indeed true that the hypotenuse squared is equal to the two other sides squared and added together. Now, some of you have learned labels for your sides of adjacent and hypotenuse and opposite, that's fine. In like the context of what we're going to talk about, we don't need to know adjacent and opposite. We really just need to know what the hypotenuse is. But I have no issues with you working with those things. It will eventually become useful to you later on, but for right now, it's not a major. So I'm not going to use them, but if you do, that's okay. Right, so this is what Pythagoras says if you want to take a screenshot of Pythagoras' theorem. The hypotenuse squared is equal to the sum of the squares of the two other sides of my right angled triangle. But we obviously need to be able to actually use this theorem. So I'll give you another second or two if you want a screenshot, and then we're going to have a look at some examples. Okay, so if we have a look at our first question over here, question A, the first thing we want to try to do is identify for ourselves which side is the hypotenuse. So the hypotenuse is always opposite your right angle. It will also always be the longest side in your right angle triangle. And so what I see is that the side AC is my hypotenuse. Okay, now that's just useful in terms of being able to use the formula. Right. So now we want to go and work out this unknown length. So we want to work out the length AC. This is saying to me that AC squared, which is the hypotenuse, is equal to the sum, so plus the square of the two other sides. So 36 squared plus 15 squared. Now, this is like a geometric reasoning, so we should actually put the reason Pythag or Pythagoras next to our initial statement. It's not a huge issue right now, but it is eventually going to be something we're very strict about. So rather just get into the habit now. It just will make your life easier later on down the line. So we've got that. You can put this straight into your calculator. There is no need for you to work out 36 squared and 15 squared separately. If you want to know what those are, AC squared is equal to 36 squared is 1,296. 15 squared is 225. So I need to add those two values together, and I get 1,521. Now, I want AC. I don't want AC squared. So I need to square root both sides in order to get AC alone. And when I go and square root 1,521, as some of you have already said on the chat, we get a length of AC is equal to 39. Now, AC is a length. I have told you that these lengths are in centimeters, so you need to have centimeters with your answer. You can lose marks if you don't put the units there. So your answer should be 39 centimeters. Right, so I hope that wasn't too complicated, but if we have any questions, please do put it in the chat or raise your hand. Take your screenshot, and then I'm going to ask you to try, hopefully, the next couple by yourselves. While I'm waiting for everyone to screenshot, can we just give a thumbs up, thumbs down how we felt with the specific question of working out the hypotenuse? You can put it in the chat or you can react. Don't really mind. Were we okay with this question? Good. Nice, guys. Excellent. Okay, so I want you to give question B a try. So again, identify for yourself which side is the hypotenuse, and then try and use your theorem of Pythagoras in order to go and solve for the unknown length x. If you have an answer, or when you have an answer, you can pop it in the chat for us, but I'm going to give everyone a chance to have a try before we have a look at the answer. Very loud people outside. I don't know why we have to stand in the street and scream. Okay, I'm seeing lots of hands. Seeing some answers coming through on the chat. Okay, Latabo, do you want to give us an answer here?
Hi, ma'am.
Hi.
Yes, ma'am. So I would like to answer.
Cool.
So then my equation will be x squared is equal to 9 squared plus 12 squared.
Good.
9 squared plus 12 squared equals to 225.
Perfect.
Then you square root both of them.
Good.
And then the final answer will be x equals to 15.
Perfect. Well done. Now, guys, in this case, I didn't give you what units the lengths were in, so we would actually just write units there. There's still some units of length. It is a length. We just don't know what that unit is. So we need to write units there with our answer. But exactly as been explained, 9 squared plus 12 squared, you don't have to do the calculation separately. You don't have to say 81 plus 144. You can just type it straight into your calculator as that and get your 225. We want x alone, so we need to square root, and so we get 15 units. Okay, if your hand is up, I'm assuming you have a question. If you don't have a question, please lower your hand. There will be more opportunities for you to answer, so please don't stress. Before no, okay, there we go. Alrighty. So I'm going to give you two now, C and D. I would like answers for those two X values. So in the chat, you can label your answers C and you can label your answers D as you get them. Again, we're using Pythagoras because we've got right angled triangles. Think about where your hypotenuse is, or which side is your hypotenuse, and how you're then going to solve for each of them. Okay, and if you are feeling brave, or if you're feeling like you would like to, you can raise your hand to give us an answer, or you can pop it in the chat. Just remember to make clear which answer you're giving. Is it C or is it for D? Remember your units for your answer. Sometimes you will lose marks if you don't put units with your answer. So don't lose marks for a silly reason like that. Ooh, excuse me. Seeing some great answers coming in on the chat. Well done. Just remember those units. Okay. Tabang, do you want to help us out with question C?
Yes, ma'am.
Okay.
So, let me say hypotenuse squared, ma'am, which is x squared.
Good.
So x squared equals 15 centimeters squared plus 5 centimeters squared.
Okay. I don't know what's happening with my pen. So, oh, okay, there we go. It's decided to. Righto. Okay. X squared is equal to, say it again, 12 squared plus 5 squared.
Yes, ma'am.
Perfect.
Which is equals to 169.
Cool.
I mean, yes, ma'am. Equals 169.
Good.
And then you divide x squared and 169.
What are we dividing? Aren't we square rooting?
I mean square rooting.
Good.
And then that would be 13.
Excellent. And
X
what?
equals 13.
13 what?
13 units. Centimeters.
Centimeters. Excellent, Tabang. Well done. Okay, guys, there we go. So our answer for C, as Tabang has told us, is 13 centimeters. Zali, do you want to give us D? Whoops.
Yes, ma'am. I'd like to give you D, ma'am.
Perfect.
So I said x equals 4 centimeters squared plus 3 centimeters squared.
Good.
Then I got the answer of 25.
Perfect.
So I said x squared equals to the square root of 25.
Good.
Then I got the answer of 5.
Perfect. 5 what? What should our units be?
5 centimeters.
Fantastic. Well done.
Yes, ma'am.
Excellent. Okay, guys, so there we go again. We have got 5 centimeters for our question D. Okay, so what we need to be mindful of here is whether or not we are putting our units. Like I say, like sometimes we can be quite strict and you can lose marks for not putting units in. So please make sure you do that. And then remember that when we are trying to get the x alone, we're square rooting. And so we need to square root the value of the two other sides squared added together. Right, but we're on a roll here, so well done. We do have our brain break next, but obviously because Teacher Sam is who she is, she just decided to use the same stuff from last time, but it's fine.
Are you gonna try to find the other one that we did?
No, she's just losing her mind. I'm just okay. Everything's fine. Do not panic. Right. I have to find another one for next. Chaos.
I'm joking.
I know. I thought I was
There we
so
go.
on it, and I was not on it. Okay. Rebetme, it's not 5 units for D. It's 5 centimeters because I did tell you it's centimeters. Okay. So just be careful there. Right, guys. So here is your brain break. Yes, I know the joke is the same. I apologize. I had a moment. I thought I was prepared. I was not prepared. It's okay. So here's our brain break. We're going to do the same as last, or as we have been doing it, with the first person to get the answer. Gets the answer. And will then explain it to us. So have a look. You need to get the value of, oh, golly, I'm really just having a day. You need to get the value of this last expression over here. Okay.
Let's see, my babes. I haven't seen the correct answer yet. Whenever I see the correct answer, I'll let y'all know. Let's go. So we want the full answer, right? Not steps. We are giving the final answer. What are the glosses plus the hill plus the fire, those two fire cap equals to? That's the final answer we are looking for. So you do the calculation on your side and we just need the answer. Put it on the charts. Once I have confirmed on the charts that you got it right, then you can raise your hand and then you can give the answer. So far, I haven't, it's not 56, my pibs. Let's continue. Let's go, let's go, let's go, let's go. It's not 96, it's not 104, it's not 136, it's not 25, it's not 157. Let's continue. I haven't seen the correct answer. Let's go. Make sure that you do your calculations nicely. Whoa, I've seen the answer. I have seen the answer. Who is our winner? Linneo is our winner. Linneo, Emmanuel. Well done, well done, well done. So far, it's Linneo, Emmanuel, Lufuno. That's the correct answer.
Well done, guys.
Linneo got it right first, my pib. So Linneo, if you want to explain to us how you got the answer, please raise your hand so you can explain. Emmanuel also got it right. There we go, Linneo. This is all yours. Explain to us.
Good evening, ma'am.
You mean?
So we found out that the value for the boots is 3 already.
Yeah.
Then 3 plus 6 gives us 9.
Good.
Then 3, then they give us the answer, which was 12 at the bottom there. So we said 3 plus the sunglasses, which is 9, gives us
Good.
12.
Good.
Then for the glasses, that's we said 9 plus thingy. For the shoes, which gives us 7. So 9
Good.
plus 7 gives us 16.
Good.
Then at the bottom, the final sum, which is sunglasses plus shoe plus helmet. So it gives us 9 plus 7 times 12 because there's 2 helmets, which gives us 93.
Okay, now which operation do we do first?
Ma'am, the times.
Good. So what is 7 times 12?
Done.
Ma'am,
What's 7 times 12?
ma'am, it's 84.
Good. And so 84 plus 9 is exactly as Linneo said, 90. Ooh, 93.
Yes, ma'am.
Well done.
Well
Thank
done,
you, ma'am.
Leo. That was good.
Nice, guys. I apologize. Genuinely, I've prepped like the next 3 weeks and I just couldn't get the brain break right. So we'll try again next week. I mean, on Wednesday. Things happen. Okay, well done. For anyone who is new, don't stress about these. This is more just an opportunity to take a little break from what we're doing before we carry on. So we've sort of developed it into a competition of who can get it right first, which is awesome. Theo, I see your hand up. Do you have a question before we move on? Okay, I'm going to take the silence as a no. But if you do, obviously just raise your hand. Okay, guys, so, oh no, there we go. Theo, do you have a question for us?
It's okay.
Right, guys.
Theo can ask on the chat or whenever he's ready, he can ask.
Okay. Right, guys, so we've had a look at what happens when we're looking for the hypotenuse, which is great. But what happens if we're looking for a length that isn't the hypotenuse? So if we have a look at this first question here, I can see that the side opposite the right angle is xz. And in this case, I've actually given you what the hypotenuse is. And so now what we're actually being asked to find, because that makes all the sense in the world, what we've been asked to find now in this case is a length that is not the hypotenuse. We've been asked to find the length of xy. Okay, now some of you will have learned that you can just immediately go and subtract. I'm going to substitute so that we can see why we do that. So let's go back to what Pythagoras says to us. Pythagoras says we take the hypotenuse squared. Now we know the hypotenuse, it's 30. So 30 squared is equal to the 2 other sides squared and then add it together. So 24 squared plus xy squared. Now I don't know xy, that's what I'm trying to solve, but that's fine. And now if I look at the equation I've set up for myself here, I know that I want to essentially isolate this xy squared. Now, because this is a plus 24 squared, if I want to essentially use my inverse operations, I'm going to have 30 squared minus 24 squared on the left, and that will give me xy squared. And now what I've done is I've essentially isolated the thing I'm wanting to solve for. Now, again, you can just do this on your calculator. There is no need for you to there's no need for you to tell me what 30 squared is and what 24 squared is separately. 30 squared minus 24 squared is then 324, gives me xy squared. And we sort of now follow the same logic. I don't want xy squared, I just want xy, so I'm going to square root both sides. And if I square root 324, I end up with 18 centimeters as my length of xy. And so when I'm solving for a side that is not the hypotenuse, I'm going to essentially subtract from the hypotenuse one of the sides squared, which is what we've done here. So nothing too complicated. We just have to bear in mind that now, because we're not solving for the hypotenuse, my operations look a little bit different. But the method is the same. We still use this thing, English. We still use the same theorem, the same substitution. It just means that when it comes to our actual operations and solving for our unknown, we do need to do a subtraction instead of an addition. Right, so take your screenshot. If anyone has any questions before we move on, please do let me know. Like I say, the concept of Pythagoras and being able to use Pythagoras is very, very important. We're going to use it many times in many different sections, so we do need to be comfortable with it. Alrighty, so I would like you guys to have a try at answering question B. So question B, remember, think about where your hypotenuse is. I'm wanting you to solve for side X. And so substitute into your theorem and solve for X for me. If and when you're ready, you can put your answer on the chat or you can raise your hand and then we'll see what we get. Remember your square roots, and remember that if you are not solving for the hypotenuse, you're probably going to have to subtract, or you are going to have to subtract.
We can do this, my babes. Let's go.
Right, if we're struggling a little bit, it is okay to get a decimal. So if you're getting decimals, don't panic. Sometimes we do get decimals. It's absolutely fine. Don't stress. Okay, I'm seeing some good answers. Emmanuel, do you want to help us out with this one?
Yes, ma'am.
Okay.
Ma'am, I don't mean to rebel against your methods, because I did a different method.
Okay, rebel away. It's fine.
Sorry, I muted someone who was talking because of the noise.
Oh,
Sorry.
can you hear me?
Yes, we can hear
Yes, now we can hear you.
you.
Okay. So I said
Emmanuel
21.
was busy rebelling against me, so let's see
You
where
know?
this takes us.
Um,
Okay, tell
so
us.
so I said 21 squared equals x squared plus 8 squared, and then I
Yeah.
got ma'am, it's different, ma'am. So I said x squared equals 21 squared minus 8 squared.
Yeah.
And then I said x equals square root of 21 squared minus 8 squared equals x equals 19 comma 41.
Okay, good. So I am perfectly happy with your rebellious methods.
Wow.
Absolutely fine. I haven't
Well
written
done.
it down purely because I don't want to confuse anyone, but your rebellious methods are absolutely fine.
They
Rebel
also
away.
work.
Yeah.
I
Okay,
am
so guys,
strong.
basically Emmanuel was, and honestly, where Emmanuel's at is probably where we want to get to, is actually putting everything all in one step. So rather than doing a step-by-step calculation of first saying 21 squared minus 8 squared and getting an answer of 377 and then square rooting, what Emmanuel's actually gone and done, and as you get more comfortable with the stuff, you'll get there, what Emmanuel's actually gone and done, and he said, okay, well, I know that I'm eventually going to have to square root that whole answer. So why don't I just go for it? So Emmanuel's gone and said the square root of 21 squared minus 8 squared will give me x, essentially. And so what he's gone and done is essentially almost everything in one go, which is fine. But obviously, if you're not yet comfortable with that, rather just do it step by step. Right, the next thing I just want to chat about is rounding, because it's a thing that, like, I think sometimes we assume we know how to do, or your teachers assume you know how to do, but we aren't always super comfortable with rounding. So I'm going to write all of the decimals down quickly, just so that we can chat about it. Now, I didn't give you any units here, so this would just be units. If we are going to round off, now generally, rounding off is to 2 decimal places, but you must read the instructions in the question or in the instructions on the cover page. It will tell you what to round off to. 9 times out of 10, it's to 2 decimal places. Now, what that means is the following. If I want to round off to 2 decimal places, I essentially want to stop my number. That's a terrible line. I want to stop my number after the second decimal point. And so what that means is I want to essentially ignore everything to the right of that line. However, what I need to first do is check the 3rd decimal and see if it's going to have any effect on my 2nd decimal. Now, if your 3rd decimal, or whatever you're rounding off to, is 5, 6, 7, 8, or 9, the 2nd decimal, or the 2nd decimal number has to increase. So in this case, this would need to increase to x is equal to 19,42. We round up. However, if that 3rd decimal was anything below 5, so 0, 1, 2, 3, 4, we leave it as it is. It won't round up. It'll stay as it is. So just a very quick side note on rounding. Generally, it's to 2 decimal places, and just double check whether you need to round it up or whether you can leave it as it is. Right, so I'm going to leave this here in case you want to screenshot, and then we're going to have a look at another one. Alrighty. Now, if any of you are feeling comfortable with Pythagoras and want to give Emmanuel's, I don't know, rebellious ways a go, by all means, give it a try in the next one. Right, so here's question, actually, let's just put both up. Question C and question D. I want you to try, whoopsie, those 2 for me. Again, you can put your answers in the chat with C and D, and if you have an answer, you can raise your hand. And I would really like to do question 3, because I think you guys can definitely manage it. So let's hopefully we get there. But have a go at those. Put your answers in the chat or raise your hand, and then we can go from there. I'm still having a giggle at Emmanuel saying he's rebelling against me.
Y'all can do this, my babe. Let's go.
And again, guys, remember, if you're getting decimals, that's fine. Sometimes we get decimals and that's okay. Just round off to 2 decimal places. Or whatever the instructions tell you. I'm going to say 2 decimal places. Okay, I'm seeing some good answers for C. That's good. And I'm so glad we are remembering our units. Okay, I'm going to give everyone another minute and then we're going to get some answers from those with hands up. And Paul, well done on that rounding. Excellent. Okay. And Loso, would you like to give us the answer for C?
Yes, ma'am.
Okay.
Hi, ma'am.
Are you rebelling against me as well?
Ma'am, my answer was 10 squared equals 8 squared plus sine squared. Then 100 squared equals 100, and then 8 squared equals 64.
Okay, sorry, I don't know why
Plus
I'm being so slow. Yeah, keep going. I'm getting there.
plus 60. Oh, plus sine squared. 100 minus 64 equals sine squared. And then 36 equals sine squared. Square roots 6 centimeters.
Okay,
Equals
cool.
2.
I'm getting there. I'm getting there. I'm sorry, it's taking me so long today. I also can't write the numbers down.
Oh, sorry, man.
No, you are perfect. I am being useless.
Thank you, ma'am.
Right. Good. Well done. So in the end, oh, okay, it's fine. In the end, we get an answer of x is equal to 6 centimeters. Excellent. Oh, okay. It's gone very badly for me. But well done, Floso. That is exactly
Thank
it.
you, ma'am.
Okay. So guys, there we go. For question C, we should have gotten 6 centimeters for the length of x. Leah, would you like to give us question D's answer? Leah, are you there?
Let's go, Leah. I think Leah is having problem with unmuting, but I see Lady had Litabo, Lideo. So while Leah is trying to sort out that, we can move.
Okay, Tato, do you want to try for us? Question D.
Yes, ma'am, I'm still calculating though.
Okay, well, let's do it together. So where would you start?
I said 7 squared equals to 1 squared plus x squared.
Perfect. So what would I now do as my next step?
X squared equals to 1 squared minus 7 squared.
Okay, so just remember we want to bring the 1 over, so it'd be 7 squared minus 1 squared.
Yes.
Okay, cool.
Then it'll be 48.
Good. So x squared is equal to 48. And then what do I need to do?
Square it.
Exactly. So I'm going to square root x squared and I'm going to square root 48. And then what do we get?
6,92.
Okay, so 6,9282, so on, so on, so on. If I say round off to 2 decimal places, this 8 needs to increase my 2. So this would be x equals 6,93. And it is millimeters this time. Well done, Tato.
Thank you, ma'am.
Okay, very nice, guys. So I saw some very good answers there in the chat. Lots of you remembering your units, which is excellent. And just remember your rounding, because the 3rd decimal was an 8, it needs to increase my 2nd decimal to a 3. Okay, I know rounding is sometimes like, we just assume we know what we're doing, but sometimes we get it a bit funny. So please do ask if you're feeling stuck. Okay, so I've got this fun one here for us. Or rather, take your screenshot of those two and then we'll look at the fun one. So I'm going to give you like a minute or two to try it by yourselves. My advice, if you're feeling stuck, draw like a picture for yourself to try and visualize what's going on here. And bear in mind, what we're working with is Pythagoras. So your picture maybe should have a right angled triangle somewhere. So here's our fun one. A ladder is leaning against the side of a 10-meter tall house. If the base of the ladder is 3 meters away from the house, how tall is the ladder? So I'll give you a second to think about it. Like I said, try draw a picture if you're feeling a bit unsure. It doesn't have to be a beautiful picture, but give it a try. I'm going to give you like 2 minutes and then we'll chat through how we would deal with this. But my hint, we're working with Pythagoras. So see if you can draw the picture so that you've got a right angled triangle somewhere. And often, guys, when we do have word sums in maths, sometimes a picture is quite helpful for us. Doesn't need to be a beautiful picture, but sometimes it is a little bit useful for us to actually visualize what's happening. And I can see Sasha diligently drawing her picture. It's great. Yo, Atlakhan's already got answers here.
Y'all don't forget your unit. My pips are doing well, teacher Sam.
Lovely, guys. You're also on it. Oh, guys, hey, your dedication here just makes me so happy. I'm going to give everyone another minute or two to try and get an answer. Remember your units in your answer. And this, guys, is an example of like a more problem-solving type of question. So this would be considered quite a hard question because I'm expecting you to visualize something without a diagram here. So well done on giving this a go. Remember your units. Hey, Lolita, do you want to help us out here?
Hello, ma'am.
Hi.
So I said, is it okay if I said AC squared?
Sure, yeah.
So I said AC squared is equal to 10 squared plus 3 squared.
Good.
Then I said AC squared is equal to 109 squared.
109.
Yes, ma'am.
Okay.
Then I said the square root of AC squared is equal to AC. Then the square root of 109 is equal to 10,44 meters.
Excellent. Well done. Okay, guys, so in order to visualize what's going on here, like I say, sometimes it is useful to draw a picture for yourself. So we've got a ladder leaning against the side of a 10-meter tall house. So here's my house. It's not a beautiful house, but there's my house. Okay, so 10 meters tall. Now we know that the house and the ground are at 90 degrees to each other because you've got flat ground and then a house is at 90 degrees. I've then got my ladder, which is this beautiful line over here, and it is leaning against the house, and it is 3 meters away from the end of my house. And so what I've actually got here is a right angle triangle. if I sort of trace over it, there's my right angled triangle, which means that I can use Pythagoras to work out how tall or how long the ladder is. And so that's exactly what we've got here. If we take 10 squared plus 3 squared, we're going to get the length of my ladder squared. And in this case, we used AC as the length of my ladder, which is fine. If you used X, if you just used, I don't know, ladder or whatever, it's cool. But as long as you worked out the length of your ladder as 10,44 meters, that is perfect. Linnell, do you have a question? No? Oh, excuse me. Right, so I'm hoping we all got that. If you didn't get